So, welcome back, first of all, in-person people and video people. Welcome back to Schoology, I guess, for virtual people. So, because we kind of squished up differential equations at the end of last 9 weeks, because we wanted to get that group and open note, or that last test in there to help your grades, which it helped most of you, probably helped all of you. We kind of squeezed out one little piece of differential equations. So we'll do that today, and then I'll throw that in as a bonus for on the test next week. And I don't know yet. This used to be a block day, so it used to be a block day test. So I need to figure out sooner rather than later if this is a 2-day test or if I can just chop it down and give us a review. We'll figure out. We do have block this week, not next week. Next Friday we're off. And after this next test, after next Wednesday, Thursday test, we start reviewing. And so that's the end of the new material. So that's kind of nice. Like, we're done with new stuff. And then, so we still have tests, but they're just over review material stuff. So we'll take a practice AP test, and then it's just a whole bunch of review. By the way, there's some important dates coming up. This thing is posted, this calendar is posted in Schoology, so if you guys at home want to print one out, or if you guys here want to print one out, I will have copies for you later this week, so if you can wait, I'll have one for you. But it's got the important dates on here as well, like Thursday the 15th is senior picnic, so probably won't see you that day. That Friday is prom. I don't know if I'll see you that day either. Some of the girls are shaking their head. Guys are like, what do I got to do? Put a tux on. Like, I'm done. Like, that's all it takes. Girls require a little more. Careful what word of choice I picked there. Time. We'll just say time. Almost said maintenance. That's not really the right word I'm going for. The girls are like, no, don't say that. The time. I'll phrase it this way. The guys, there's just not much to work with, right? So you just kind of give up and go with what you got. Girls, that won't look good. So, whatever. You are not going to be here this day, probably, many of you. And then the 19th, the Monday after prom is, I shouldn't officially put that on there because that's not officially, of course. But many of you won't be here that day. So those days are listed as review because I can't just put nothing, but you're not going to miss anything if you're not here. Starting in May, the AP test I put on this calendar because I know many of you are taking multiple AP tests. Here's the, I don't want to say most important one, but most important one to me anyway. The others are listed there so you can start to figure out what days you'll be here and what days you won't. During these last 2 or 3 weeks, a lot of you guys are going to be in and out because you've got other AP tests. And we absolutely understand that is more important, especially once our AP test is done. That's what's most important. Like, you've worked all year to do well on these AP tests. So in here, we're going to start you get the choice of which project you do, and we'll talk more about these later. And we'll just use those 2 weeks for the days that you're in here, you can work on that project. If you're not in here because you're taking an AP test, no big deal. Like, that's more important. And so there's a whole bunch of days that just say name/video project. That's free. It's not free time, but it's time for you to work in class on that project. So you're not free, but there's no homework. And if you miss a day because you're taking, chemistry or psychology or whatever, no big deal. Like, just the days that you're here, you can work on the project. The days that you're taking the AP test, worry about the AP test because that's definitely what's most important. And so we need another test grade is one of the things. Gives you a little bit of something to do, and it allows you to focus on your AP test. So after May 4th, I don't want to say we shut it down in here. We definitely dial it back, put it that way. A little bit of an exception for I think one person in here that's dual credit. On that Thursday, we'll take a dual credit exam. I don't know why there's not any AP test on that Thursday. That seems weird to me, but that means all my dual credit students are not taking an AP test because there aren't any AP tests. So I just put it on that Thursday. If you're not dual, which is most of you, then you'll keep working on your name/video project. And so, plenty of time to complete that project in class. It's due for a test grade on the Friday before the last week of school. They haven't said officially what finals will look like, but I'm guessing that it's going to be like first semester where it's like an optional, not optional, it's a test. If you skip it, it's a test that will replace a previous grade. But if your grades are good enough as they are, you won't need to take the test, and it's sort of like an exemption. I assume that's what they're going to do, so I don't know. We'll figure that out later. So that's kind of the overview of the semester. So I need you in person and you people online to be engaged with me until May the 4th, okay? So this isn't shut it down time yet. You're still going to get to shut it down early. After May 4th, for me, we're pretty much done. Like, this project is not a difficult project. It's a fun project. Students have fun doing it. It's not a big deal. But I need you to stay with me through May 4th. And some of you guys that may switch to virtual or start taking virtual days or whatever, I get it. I'd rather you be here, but you need to keep up because we're going to review everything. We're going to review everything before we see the test again. So we finish new stuff next week, and then we start, like, you look at these and you're like, oh, I remember that, limits. We did that a long, long time ago, so we need a day to go over that. Differentiation, that's taking derivatives. Well, we're going to do 1 day on it, looking at graphs. So we're going to hit everything again. So stay with me, stay engaged, and we will definitely be ready come May the 4th. Any questions on the calendar? All right, that's the longest I've ever spent talking about a calendar. Growth and decay. You've seen those words in pre-cal and maybe even algebra 2. Today we're going to kind of see where that comes from. So let's just start with a box and then we'll figure out where it comes from. If y is a differentiable function of t, so some function of time, where y is greater than 0, and then here's a differential equation, y prime equals k times y. Well, let's stop there for a second. That means dy dx equals k times y. So let's separate variables, integrate both sides, do some algebra, and see where we get. So I'm going to move the y over, move the dx over. This is how we ended right before spring break. Separate the variables, integrate both sides. K is a constant, so I can have my integral with k outside or inside. It doesn't really matter. What's the antiderivative of dy over y? Natural log of y. And the integral of dx would just be x. So kx plus c. Then we do the fishhook thing. E to the kx plus c equals y. And then we do the magic algebra trick where that c is really e to the c, which means we could change it to a different c. E to the k. We were in t's rather than x's, so I'll switch it to a t. So that's exponential growth and decay. If the rate of growth is proportional to how much stuff there is, then that's exponential growth. So that means the more stuff there is, the faster it grows. And then that means there's more stuff, and so it grows faster, and then there's more stuff, and it grows faster. And that's why the graph goes up really high, because you start out with a little bit, so the rate is slow, and then you start getting bigger, and it kind of blows up on you. There was a epidemiologist I saw on Twitter last night said something about talking about COVID. That's the thing with exponential growth. It starts slow, but when it explodes in a hurry. And that's exact. Here's the calculus behind it. I almost nerded out and replied to him, but I let it alone. All right, so example 1. That, by the way, this means that if you recognize that this is the case, you don't have to go through all of these steps. Now, these steps go quick, but if you recognize that this is the case, now we can say, well, you know what? I don't need to go through all that. I'm just going to jump straight to the sort of the final form of the answer. So if you recognize it, you can do that. If you take a couple minutes to kind of wind your way there, that's okay as well. Example 1. 10 grams of plutonium was released in the Chernobyl nuclear accident. How long will it take for the 10 grams to decay to 1 gram? Half-life is 24,000 years. All right, well, we're going to jump straight to the formula, because why wouldn't we? Let's just go y equals c e to the kt. And let's start a table of values with the stuff that we know, because I think that will help. This will help us on all of these problems. So when it was first released, there was 10 grams. We want to know how long will it take, so we're looking for the time when we get down to 1 gram. But we also know that the half-life is 24,100 years. That means after 24,100 years, how much plutonium will I have? If we started with 10, we'll have 5. All right. The other nice thing about just jumping in and starting at this spot is that C is the initial value. So I don't have to do a whole lot of plugging in. Like if we know where we start, that's C. So y equals 10 e to the kt, because my initial value is 10. We almost always know that. I mean, they can word a problem where you have to find that, but usually we start with some known amount and we want to know how long it takes to get to something else. Okay, so I don't know k, right? Like I'd like to plug in 1 for y and then figure out what t is, but I can't do that yet because I don't know what k is. So I'm going to use this piece of information to figure out what k is. So let's see, let's divide both sides by 10. How do we get that 24,000 K out of the exponent? Algebra and pre-cal experts. Natural log both sides. Natural log of 1/2 equals, let's see, how many steps do I want to skip? None yet. We won't be skipping steps. We natural log both sides because that means the exponent can now come down front as the coefficient. So natural log 1/2 equals 24,100 K times natural log of E. Should have warned you to write small in this example. What's the natural log of E? 1. So K is equal to natural log of 1/2 over 24,100. Grab a calculator, unless you know what that is without a calculator. 12 pi. We're going to offer some guesses.
3 and 3.
It's going to be negative because natural log of 1/2 is negative, and then divide by 24,000 is going to be small.
Negative
I'm not even going to write that down, okay? So here's some calculator stuff. Like, I don't want to have to write that down, especially to all those decimals to get it right. So I'm going to store that, stow, as, I guess we'll store it as k, since that way we'll keep things consistent here. So store it as k. When I pressed the stow button, it said answer arrow k. So now my calculator knows what k is. Anytime I need it, I don't have to type it in. I'm just going to hit k. I mean, you can also verify that if you're not sure. Yep, there's k. And you can just leave that. Like the grader on the AP test is going to know that's what you did. They don't even care that you write out what k is. You got to solve for it, but you don't need to write it out. Now, the reason we were doing this problem is to figure out this question. So when y is 1, 10 e to the k, but now k is a constant. K is known. K isn't a variable that we're looking for. Like, we know k. So now we're solving for t. There's a lot going on here. So 1/10 equals e to the kt. Again, natural log both sides. Some of these steps you'll start to skip. I'll skip one here because I know the natural log of e is 1, so I'm not going to write that down. And again, this feels weird the first few times you do it because it's like, well, I don't know what, I got two variables there. No, you don't have two variables there. You know what k is. I don't want to write it down because it's ugly, but I know what k is, so I can solve for t. And now I'm just going to go to the calculator and type that in. Right? I've never once written out what k is because I don't, that's ugly. So natural log 1/10 divided by k. Let the calculator handle all the ugly numbers. 80,058. Well, we're supposed to do 3 decimals. That seems a little overkill for this problem, but always 3 decimals on the AP test. 80,000 years. Let's see if that makes sense. So back on our table of values, 80,058 years. Well, it took 24,000 years to get down to 5 to cut it in half. So if we cut it in half again, it would take another 24,000 years. So this makes sense. Like, just writing it out, you will see if your answer doesn't make sense or not. Like, it should take a long time to get down to 1. Number 2. A bacteria culture starts with, that sounds like C, initial value, grows at a rate proportional to its size. So here's where we need to start recognizing it didn't say exponential growth, but that means exponential growth. Grows, so y prime, proportional to its size, so k times however much there is. I'm not going to solve this because I know what the solution is. The solution is c times e to the kt. After 3 hours, there are 8,000 bacteria. Again, a table of values I think will help you make sense of your answers to see that they fit the pattern. So at time 0, we start with 500. After 3 hours, I'm kind of peeking ahead so that my table goes in order. So I want to know something about 4 hours. I know something about 3 hours. And when will it get to 30,000? So at 3 hours, there's 8,000. At 4 hours, how many are there? And then when there's 30,000, what time was it? So this is a lot of problem multi-step problem here. A lot of questions about this. Part A, find an expression for the number of bacteria after T hours. Just write the equation. But I already know C. Start with 500. How am I going to figure out what K is? What's that? I can't use 0. It's a good question. In fact, if you use 0, you get C is 500. So C equals 500 means we've already used that point. So let's use the next one. So 8,000 equals 500 times e to the 3k. This is kind of the same problem we just did last time. 8,000 divided by 500 is 16. Natural log both sides. How ambitious do I want to be? Not yet. So natural log of 16 equals 3k. And k equals natural log 16 over 3. So my answer to this question, I've told you about my favorite Facebook group. This came up like yesterday or day before. Like, can I leave this as my answer because I've told you what k is? And one of the graders said, yeah, you can, because there's your equation, and you've said what k is. So, if it makes sense to you to write it all out, that's fine. If you're good at looking at this and saying, well, I know what k is, so I'm good here. The combination of these two answers the question. If that's bugging you and you want to write it out, you can. Find the number of bacteria after 4 hours. So y equals 500 e to the k times 4. But I know what k is, so again, you don't get this. I'm not looking for k. I know what k is now. In fact, I might want to type it in since I'm going to use it several more times. Log 16 divided by 3. Then I will store that as k. It wasn't too bad to type, but since I'm going to use it multiple times. So 500 e to the k times 4. And there's my answer. And I don't have to show any more than that. This would definitely be a calculator problem. You've shown your work. That's calculator ready. So the answer would be 20,158.737. I might fill that in on my table over here. When will the bacteria reach 30,000? So now it's the other problem. I know the y, and I'm looking for t. Why don't you try that one? I'm going to press pause. You guys at home try that. We'll come back and figure out what t is. So we move things around a little bit. Natural log both sides. K is already in the calculator, so I don't have to keep retyping that. Natural log 60 divided by k, 4.43. Years. No, not years, hours. We're in hours. And that fits the pattern. So if you make a table of values, again, you'll catch if something seems out of whack. So it's nice to make a little table of all the information you've used and you've found to see that It fits the general pattern of growth or decay. All right, let's do one more. We're not going to do example 4. So we will do example 3 because there was a problem like number 3 on an AP test a couple years ago. Students came out crying about the potato problem. If any of your siblings took calculus, I don't remember, 2 or 3 years ago, they would probably remember crying about the potato problem. Newton's law of cooling. The rate of change in the temperature of an object. So rate of change in temperature of an object, that would be d. We're going to use U for temperature just to avoid the multiple T's. du dt is proportional to, so equals K times the difference between the temperature of the object and the temperature of the room. Now, you're not expected to know Newton's law of cooling. So if they gave you a problem like that, they would most likely give you that statement and probably even the formula that goes with it. Because that's too specific for them to have you remember it. They would give it to you, and then you'd have to be able to use it. But I think that makes sense. Like the bigger the temperature difference, the faster it cools. Right? If the temperature difference is really small, it doesn't cool as fast. Suppose that a roast turkey is taken from an oven when its temperature has reached 185. Again, I'm already thinking table of values here with what I know and what I don't know, and kind of fill in the blanks here. So at time 0, the temperature is 185. Placed on a table in a room where the temperature is 75, so the room temperature is 75. So that doesn't change. Oh, I guess in theory it changes a little bit because as the heat comes off the turkey, it heats the room, but not enough to worry about. If the temperature of the turkey is 150 after half an hour, what is the temperature after 45 minutes? That's just kind of annoying. You see what they did there? We've got a units problem. They're trying to mess with you. So I guess we need to figure out, do we want to work this problem in minutes or hours? Minutes, because you don't have to deal with fractions. That's fine. So at 30 minutes, we're at 150. What is the temperature after 45 minutes? And then, when will it have cooled to 100? So,
no, it's going to be like 137.
Throw some guesses out there.
Oh wait, I'm going the wrong way.
So let's write down the guesses. Tyler says 137.
I'm going to go with 142.
Oh no, I think it's going to be lower than 130s.
I'm going to go 142, man.
Okay. Tyler, you're sticking with 137. You're already on the record. Sorry.
Oh yeah, baby.
Nick, you're going 142. You're on the record. Anybody else want to go on the record with anything?
138.7.
138.7?
You know what?
That's kind of close to Tyler, but we'll let it go. All right, let's work this problem. All right. This looks like separation of variables. This is not what we had been doing. Was dy dt equals k times y. That's what led to c e to the kt. But that is not what's going on here. So we're going to have to go the long way around on this one. And do separation of variables. You've done this one enough to know what's going on here? Without using a u substitution? Natural log of u minus 75 equals kt plus c. If I'm really thinking, I probably don't need the absolute value bars because that temperature is always going to be more than 75 because it starts at 185 and it's coming down. So it's never going to cool below the temperature of the room. So I don't really have to worry about the absolute value bars. E to the kt plus c equals u minus 75. So my little algebra trick, c e to the kt equals u minus 75. And so my equation for u is c e to the kt minus 75. Now, I better be super careful because I don't think C is going to be 185. Like, that was for a different type of problem. So let's plug this one in first. Yes, it would be plus 75. Thank you. So 185 equals C e to the k times 0 plus 75. So we like times 0 because e to the 0 is 1. So C equals 110. So U equals 110 e to the kt plus 75. But now I need to know what K is. But they gave me a second piece of information so I can figure out what K is. So now I'm going to use that second line. Temperature is 150. E to the 30K plus 75. Ugh, how small can I write? Move the 75 over and divide by 110. Yeah, I didn't plan this very well. I'm going to hop over to the other side. What am I doing next? Natural log both sides.
Yeah, it is.
So there's what K is. And again, I can leave that because that's calculator ready. I'm going to need it, so I may as well type it in. And careful with parentheses, as I almost mess up parentheses. Natural log 75 divided by 110, all over 30. Some ugly number, don't care. Store that as K. And so now I've set this is K for the rest of the problem. And so anytime I use K, I've got it there. I don't have to write it out. The grader will know, okay, he found K. It's in his calculator. We're good. What was the point of this question here? What is the temperature after 45 minutes? So U equals 110 e to the 45K, which we know K now, plus 75. So that's a calculator problem. Let's see who's closest.
So intense.
110 e to the 45K, because I already know what K is. Plus 75. Tyler, what was your guess?
137.
136.929. You can't get a much better guess than that.
What turkey could that fast? Taking a turkey sitting like 450.
What's that? Oh, it wasn't Celsius. Thank you. So that fits the pattern. You don't think a turkey cools that fast? I have no idea.
I'm sitting here doing some Thanksgiving turkey. It takes at least 4 hours.
When will the turkey have cooled to 100? So that means the temperature is 100. And we're looking for T. And we'll stop there because now it's the same type problem. Subtract 75, divide by 110, natural log both sides. Unless you want to make a guess, and then we'll compare answers.
God, at this rate, 52 minutes.
52 minutes? Look. It took 15 minutes to go down 15 degrees. And the rate is slowing, so it's going to take at least 30 minutes to go down 30 degrees. At least 30 minutes. So my guess is going to be T is 116.055.
Whatever you got that guess, Mr. Wolf.
Pretty good guess, huh?
116.
All right, example 4, we'll pass on. And then number 5, we can skip.
This is a challenge. Oh, yeah. I'm getting it all on the paper.
Oh, yep. Work the following on notebook paper. Bold letter, underlined, circled. It's not a challenge. Yeah, there's no way. So we marked out example 4 and then problem 5. And then you'll also notice the answers are at the bottom. So if your friend's not paying attention, you can say, well, my guess for number 1 is 71 minutes. Let's see how we do.